Okay, this is another example from differentiating from first principles. It's a little bit of a harder example because it's got a cube term in it. But this question is exercise 8.4, question 12G, to differentiate y equals x cubed minus 2x squared plus 3x minus 1 from first principles. Remember, when we differentiate from first principles, the rule is that f dashed x is the limit as h approaches 0 of function of x plus h minus the function of x over h. So what I'm going to do first, I'm just going to work out, we're going to write down what the function of x is first. So that's our rule. We're just going to work out what the function of x and the function of x plus h is first. And that will help save a little bit of time. So the function of x is x cubed minus 2x squared plus 3x minus 1. So the function of x plus h will be to replace any x with x plus h, so it's x plus h cubed minus 2 bracket x plus h squared plus 3 bracket x plus h minus 1. Now we need to expand that. Now x plus h cubed is x plus h squared times x plus h. I'm going to expand this second term. Minus 2 bracket x plus h squared would be minus 2 bracket x squared plus 2xh plus h squared, plus, opening this next bracket, 3x plus 3h minus 1. Now expanding this, x plus h squared is x squared plus 2xh plus h squared, bracket x plus h. Now I'm going to open this next bracket, minus 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus 1. I can keep going with that. We've got another bracket here to expand. So we've got x squared plus 2x squared h plus xh squared. So I've multiplied everything here by the x. Now I'm going to multiply everything here by the h, plus x squared h plus 2xh squared plus h cubed minus 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus 1. Now just looking for any like terms. We've got x squared h there and there. Sorry, this first term actually is an x cubed. Sorry, I made a little mistake. That's x cubed. That's right. Okay. So what we've got is x cubed plus 2 and 1, that's 3x squared h. Then we've got the xh squared term. So we've got plus 3xh squared plus h cubed, and then just writing the rest out, minus 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus 1. Now that's what function of x plus h is. Now if we look back up here, the f dashed x is the limit as h approaches 0 of function of x plus h minus function of x over h. So I'm just going to work out what the function of x plus h minus the function of x is. Now that's going to take a fair bit of room, so I'll write it down here. So that's writing out function of x plus h first, and then I'm going to take away the function of x. So I'm just writing out function of x plus h. Now I'm taking away function of x, in other words, taking all of this away. So I'll do the negative of everything here. So it's going to be minus x cubed plus 2x squared minus 3x plus 1. Okay? Now I'm just going to cancel any like terms. Oh, sorry, not like terms, but anything that cancels out, I'm going to cancel out there. So we've got a minus 1 plus 1 cancels, plus 3x minus 3x, minus 2x squared plus 2x squared, and minus x cubed plus x cubed. So function of x plus h minus function of x is equal to 3x squared h plus 3xh squared plus h cubed minus 4xh minus 2h squared plus 3h. Okay, so that's the function of x plus h minus the function of x. Therefore, f dashed x, actually what I'm going to do here, I'm going to go one step further. I'm going to factorize this by taking out a h, because we know that when we do the next step and put this over, and we put this function of x plus h minus function of x over h, I'm going to need to factorize out the h anyway. So therefore f dashed x is the limit as h approaches 0 of function of x plus h minus function of x over h, which happens to be the limit as h approaches 0 of h bracket 3x squared plus 3xh plus h squared minus 4x minus 2h plus 3 all over h. Now the h's cancel and leave ones. So therefore now I can just substitute, sorry, I don't know if you saw that. Now I can substitute h equals 0 directly into this now. So it'll be 3x squared plus 0 minus 4x plus 0 or minus 0 plus 3, which gives me 3x squared minus 4x plus 3. Okay, so that was differentiating our original function, which is x cubed minus 2x squared plus 3x minus 1, but differentiating it by first principles. Now just looking at what our original function was, this is the answer. Function of x is x cubed minus 2x squared plus 3x minus 1. If I differentiate that using short methods, I would bring the 3 to the front, 3x squared minus 2 times 2x, which is minus 4x, plus 3 plus 0. So I do get the same answer with the long method, which is differentiating from first principles, and checking it using the short method. So whenever you're differentiating from first principles, you can always check that your answer is correct by doing the quick differentiation using the short method, and that way you'll know whether you've got the answer correct or not. Okay, that's the end of this video. Hopefully you'll be able to finish off exercise 8.4, question 12.